So what we have a particle which is moving on a plane which radial velocity Vr is equal to 12 meter per second, and angular velocity omega is equal to 2 radian per second. So this is your Vr and this is omega. That means it is given your theta dot. And particle is at distance r is equal to 8 meter. So particle is at distance r is equal to 8 meter. So what will be instantaneous velocity? What will be instantaneous velocity at some particular, what will be instantaneous velocity when your particle will be at r is equal to 8 meter? So we have to discuss this particular thing. So what we have to do? How you will calculate the instantaneous velocity?
Sir, by
Obviously, v is nothing but Vr in which direction? R cap direction, and v theta in which direction? Theta cap direction, isn't it? And what is Vr? Is r dot r cap direction. And what will be v theta? V theta is r theta dot in theta cap direction. And what is r? R dot. This is nothing but 12 r cap. And what will be this value? This value is 8 into 2. Theta dot is nothing but omega. This is theta cap. But we have to calculate the instantaneous speed. This is velocity. So this is 8 into 2. You can write this. So what will be velocity? We have to calculate the speed. So we have to go for magnitude part. So when we are going for the magnitude part, what will be this value? This value is 12 square plus 16 square. What will be this value? This is 144 plus 256. And I think this value is what? 400? And you can have 20 meter per second. So easy, so simple problem. But this type of problem have also came into your examination. Okay. I think this came in earlier 2016. So it will way back. But yes, very basic formula based problem is there. Now let's go for next problem. This is again r and theta is given. And what is this r and theta? R and theta is given as e to the power t, obviously in term of meter, and it is given root under 8t in the radian. So r and theta is given. So what we have to calculate? We have to calculate acceleration at t is equal to 0. So we have to just go for calculate acceleration at t is equal to 0. So what will be acceleration? Obviously, if I am talking about acceleration in term of magnitude. So what will be acceleration? What is the expression of acceleration? Anybody can tell me?
AR r cap plus a theta theta cap.
So we have a is equal to AR r cap plus a theta theta cap. Now, what is your AR?
R double dot minus r theta dot.
Very good. R double dot minus r theta dot square. Okay. So what is r double dot? E to the power t. Yes. Minus what is r? E to the power t. Okay. And what is theta dot?
Under root 8.
Root under 8. You have to differentiate this thing. So this is your AR at some particular time t. And we have to calculate what will be AR at time t is equal to 0. So what will this value? Sorry, this will be theta dot square. Sorry, this will be nothing but what? Theta dot square. So what will be this value? 1 minus 8, isn't it? Isn't it? Yahi hoga na?
Yes.
So that value is minus 7 meter per second square. Now, next thing we have to calculate what is my a theta. So what is my a theta? Let's go for this. What is your a theta?
R theta double dot
Very good. R theta double dot plus
2R dot theta.
very good 2r dot theta dot. So what is theta double dot?
0.
0. This is 0. 2. What is r dot? E to the power t. What is theta dot? Root under 8. Isn't it? Yahi hoga na? And now again you have to put t is equal to 0. So what will be this value? 2 root under 8. Now what is your acceleration? Your acceleration, the magnitude of acceleration is basically you have to go for mod a r square plus mod a theta square, and when you can calculate it, this will be 49. And what is this value? 4 into 8. So what will be this particular value? Can anybody calculate it?
It's under root 81.
Under root
81.
81. So that value is equal to root under 81, and a very nice answer, that is 9 meter per second square. So you can see, just you have to use straightforward the formula. You have to remember what is the formula and how you can apply it. So first duty is that you have to remember the formula, because a lot of people doesn't remember this particular formula, this one or this one. Okay. So these are first level of question, just a straightforward question. You can easily calculate it. Let us try to twist some questions. Let us try to go for some next level of problem. This problem is one of my favorite one, because we have to see actually what is the concept behind this particular this particular radial velocity and radial acceleration, as well as tangential velocity and tangential acceleration. The question is very interesting. So in this particular problem, there is a projectile. Okay. So we have a projectile, and this projectile is making angle alpha at pi by 4. So we have projectile and which will just making angle alpha with pi by 4. So what we have to do? We have to write the radial part and tangential part of the component of G. What is G? Is the gravitation at the maximum height of projectile. Are you getting my point? You have to just write the component of radial part, component of G in r cap and theta cap. The angle is given. This is one of the very fundamental problem you can discuss. So here, look at this particular thing. This is my projectile. The projectile angle is something like pi by 4. Now we have to find this thing at the maximum height. At maximum height. So you have to find this particular thing, component of G and R at the max, component of G in direction of R and theta. Now I can choose this as a origin. Choose kar sakte na? And I can say this is my R vector. So this is my radial part. Yes.
Sir.
And this is my tangential part. And this angle is theta. The polar angle theta, because it is just making with the x-axis. And this is my G. This is my gravity, the direction of gravity G. So what we have to do? We have to write the component of G along this axis, along radial and along tangential. So what is the most important challenge? Is that this theta is pi by 4?
We'll have to check.
Is that this theta is pi by 4?
No, sir.
No, this theta is not pi by 4. So the real challenge is that by the using the definition of projectile or concept of projectile, you have to find what will be this angle theta when you are projected something with the angle pi by 4. Let us assume that velocity is v, that you are projected it with the velocity v with the angle pi by 4. So if we are just going to calculate the maximum height h maximum and the range, the half of the range, that means r by 2, then easily we can calculate this particular angle theta. tan theta के term में तो calculate कर ही सकते हैं.
Yes, sir.
What is tan theta? So your tan theta is equal to h maximum by r by 2. Yes. So now first duty is that you have to calculate what will be your h maximum. So anyone remember what is formula of h maximum?
V sin theta upon 2g.
Any is JAM student, you have to remember this thing.
See, height, maximum height, h
Huh?
by 2 t, h by 2g.
No, for the
So u square
projectile.
by 2g.
Huh?
V square sin square theta by 2g.
That value is v square sine square theta by 2g. Please go and revise your projectile, each and every one. How you are calculating the time of flight, h maximum and range. At least you have to remember these three things. So what will be h maximum? I can put this theta is not theta, this is alpha, because alpha is the angle of projection when you have just give this velocity v. So what is alpha here? Pi by 4. Okay. So this is your v square and by 4g, isn't it? Now,
Yes.
what is your r? What is your r? What is range? What is range?
U square sin 2 theta by g.
Very good. V square sin 2 alpha है ना? 2 alpha by g. यहाँ पर मैं theta नहीं alpha ले रहा हूँ. Theta I am taking this particular polar angle. Yes. So what will be this value? This value is v square upon g. But we have to calculate. We have to put alpha is equal to pi by 4, and that value is nothing but basically pi by 2. If 2 alpha we are just going to calculate, this is v square by g. But we have to find the value of r by 2, and this value is v square upon 2g. So what will be my tan theta? 1 by 2, isn't it? So that value is 1 by 2. So you have calculated tan theta, and that value is 1 by 2. Now let us take the component of g along radial direction and along tangential direction. So one component will be go into this direction, yes, and another component will be go into this direction. Everyone is comfortable? What will be this component? G sin theta or g cos theta?
Sin theta.
Sin theta. So AR, you can write AR, that will be minus g sin theta, isn't it? That is minus g sin theta. What will be sin theta here? If tan theta is this one?
1 upon root 5.
That is
upon
1 upon root 5. How you will know? That P by B is there. So 1 by root under 1 square plus 2 square. That is minus g upon root 5. And what will be A theta? What will be A theta?
Minus g cos theta.
Very good. That will be again minus sign, and that will be minus g cos theta. And you can just put g, and what will be cos theta?
2 by root
2
5.
upon root 5. Okay. So this will be your answer, and this is the one of the best question ever asked in the Newton's law in polar coordinate. Yes, everyone is comfortable?
Yes, sir.
Okay. So this is all about the list. Let's go for a second next problem. यहाँ तक clear है ये?
Yes, sir.
है ना? So आपको basically decide करना होगा कि what is your arc direction, what is your R, and how you can calculate all these things. ठीक है? Okay. Let's go for next one. So next problem is basically the force is given as, let me go for this particular problem. So a particle is constrained to move on a cylinder, and this cylinder is given something like this. Okay. And you have, this is your coordinate. This is, you can say this is X, Y, or you can say X, Y. This will be Z. And on the surface of cylinder, this is your R. Okay. And what is your force? Your force is given as F is given. That value is minus KR. So this is your force. Okay. By the way, just tell me, what is your force here? What is your R here in the cylindrical coordinate? What will be your R?
X square plus y square.
क्या होगा R?
R sir, x square plus sir,
R
यहाँ पे
R
cap
into
plus
cylindrical
z cap.
coordinate. In the cylindrical coordinate.
Sir, R cap plus z cap.
So that value is, so this R. Now you can see R in the polar coordinate is R cap. Yes? Everyone is comfortable? So what is cylinder?
Yes, sir.
Cylinder is nothing, but you have a polar coordinate and you have height along z-axis. So along the z-axis, you have to take the Cartesian coordinate or something else. Cylinder is nothing but the polar coordinate and z. So what will be the R here? First thing should be also there. So second thing will be z into which direction? Z cap direction. Are you getting my point? एक बार यही एग्जाम में भी आ चुका है कि write down the position vector in a cylindrical coordinate. So when you will write the position vector into the cylindrical coordinate, this will be the thing. Yes. Now what will be velocity? कोई बताएगा velocity क्या होगा? Just tell me what will be velocity?
R dot.
Huh?
R dot. R cap
Very good. R dot R cap plus
R theta dot
very good. R theta dot theta cap plus
z dot z.
Z dot Z cap. Very good. Now you can also find the kinetic energy. Can you write the kinetic energy? What is kinetic energy here? So kinetic energy is half m. You can write V dot V, and that is nothing but you have half m. You have basically R dot square, R square, theta dot square plus Z dot square. So this is your kinetic energy, isn't it? Now let's try to write the acceleration part. So what will be acceleration? Anyone? What will be acceleration? बताइए.
R dot dot.
पुनीत के अलावा और बाकी लोग बताएंगे. Any JAM student can can you please tell me what is acceleration?
R double dot minus R.
Very
theta
good.
dot square.
So you have AR, R cap plus A theta,
A theta, theta cap.
theta cap plus AZ, Z cap.
Z cap.
Yes or no? Now, what is AR? Anyone?
R double dot minus R theta dot square.
Very good. R double dot minus R theta dot square. What is A theta?
R theta double dot plus
R theta double dot plus
2R theta
2 R dot theta dot.
sorry.
R dot theta dot. What is AZ?
Z double dot.
Very good. That is Z double dot. Nice. Now, अब ये सारा कैलकुलेट करना होगा आपको. So I am just giving you theory. So now, what is your force equation along R direction? What is your force equation? R double dot minus R theta dot square must be equal to minus KR, isn't it? Yes or no? You are just comparing the R cap to R cap. The force is this minus KR. So you are just going to compare it. Are you people comfortable?
सर मास नहीं लेंगे.
मास भी लेंगे. वेरी गुड. मास भी लेंगे. चलो मास भी लेना है. Okay? M into A is equal to force. Very good. Thank you. Now, what will be next one? M R theta double dot plus 2 R dot theta dot must be equal to
0.
0. Very good. Excellent. Next, M Z double dot is equal to minus KZ. True or false? True or false?
True.
True, sir.
Okay. Now you have to give me answer. आप एक एक करके आंसर दोगे. Is that angular momentum of system is conserved? Is that angular momentum of system is conserved? Because this is MSQ. More than one answer is correct. So just tell me. Is that angular momentum of system is conserved?
Along theta cap direction.
Is that angular momentum is conserved or not?
Yes, sir.
Yes. How do you know?
F theta equal to
This is 0, isn't it? There is not any external force in the direction of theta. So this whole thing can be written as M R square theta dot d upon dt must be equal to 0. So M square theta dot is conserved. Isn't it? कल की क्लास में जाकर के देखिए. This answer is correct or false? This is statement? Okay. Now, is that motion is simple harmonic along z-axis?
Yes, sir.
yes.
Yes, very good. So this is also correct one. Now, is that total energy of system is conserved?
Yes, sir.
Yes. How do you know?
Because it is like a central force.
Hmm?
It is like a central force. F equals to minus KR.
F is equal to minus KR. How do you know that this is conserved?
Sir, we can also apply Poisson bracket thing.
Not needed to apply Poisson bracket here. We are just using the Newtonian. First thing is that you can easily calculate del cross F. If del cross F is equal to 0, what is the meaning of that? The force is
Conservative.
conservative. Isn't it?
Yes, sir.
In vector thing, you have learned this. I think you have learned this particular concept. When del cross F is equal to 0, that means force is conservative. And you can also see this force is not a function of time. So if it is not a function of time, obviously the energy will also not a function of time and it will be conserved. Okay?
Yes, sir.
Okay, so total energy of system is going to conserve. So this statement is correct or false?
Correct, sir.
Correct. Okay. Now these are the, is that linear momentum is conserve? Saurav, linear momentum conserve hai?
No, sir.
No, linear momentum is not conserve. You can see there is force in the R direction always. Also there is force in a Z direction. So angular momentum is conserved. Your total energy is conserved. But as well as the motion along Z axis is basically you can see is the something like harmonic oscillator. So this was also one of the very fundamental question asked in IIT-JAM examination 2018. Okay. So it was in IIT-JAM 2018. This is one of the very interesting one. Okay. So let's try to go for one more problem. Clear है ये? कुछ पूछना है तो आप पूछ सकते हो. चलो, let's go for next one. हाँ बताओ.
सर आपने जो लास्ट बोला ना लीनियर मोमेंटम कंसर्व नहीं है.
Sorry.
लीनियर मोमेंटम इज नॉट कंसर्व्ड.
Because there is force in a R direction, also force in a Z direction. अगर external force है तो angular so linear momentum कैसे conserve होगा? What is conservation of linear momentum? Just tell me a statement.
No external force should be.
If there is not any external force, then linear momentum is conserved. What is conservation of angular momentum? What is conservation of angular momentum?
Net torque should be.
Yes, if there is not any torque, external torque, then obviously angular momentum is conserved, isn't it?
Yes, sir.
So here there is not any external torque. You can see. है ना?
Okay, sir.
So angular momentum is also conserved. Okay, and you can also find from here. Okay.
Okay, sir.
Okay. चलो. Let's try to go for one more problem. Okay. So this is one of the very interesting problem. आप लोगों ने different type से इसे solve किया होगा. In fact, I think you have solved this problem from your +2 also. So there is a sphere, okay, and this sphere is just at the surface, okay, and there is a particle of mass m at the highest level, okay. So there is particle of mass m at the highest point of the sphere. So what you are going to do, you are just giving the slight push to this particular particle. आप क्या कर रहे हो? इस particular particle को क्या दे रहे हो? Slight push दे रहे हो. So when you are giving the slight push to this particular particle, what will happen to it? What will happen to it? बताओ क्या होगा?
कुछ देर स्टार्ट करेगा फिर गिर जाएगा.
After it will just slide at some particular point, and after then it will fall down, isn't it?
Yes.
It will just fall down. So what you have to do, you have to just calculate the critical value, the theta c, where this point, where this mass is going to lose the contact. Okay, so this mass m, so you have to find the critical value of theta or angle from the vertical. Actually, this theta is measured from the vertical, okay, theta, such that mass will lose contact. So you have to find the critical value of this particular theta. Okay. What is meaning of what will happen to that critical value? What is meaning? What is physically what do you understand that if it is losing the contact of that particular surface? आप क्या समझते हो अगर उस समय वो contact surface को छोड़ रहा है तो? Yes, sorry.
It's sliding till that angle theta and then
Yes.
it is falling apart.
Anyone?
Sir,
Hmm.
there won't be any normal force.
Obviously, at that particular point, normal force is going to 0. Isn't it? So what you have to do? So you have to just write the equation of motion in r cap and theta cap direction. Okay, you can write the equation of motion in r cap and theta cap direction, and then you can use the equation of constraint and the condition where normal is equal to 0. Obviously, you can calculate it. Okay, so let's try to go for this. It's a very interesting. So what are the only force acting on this particular particle?
Gravitational force.
Gravitation force. So in which direction? It will be in G direction. Okay, it will be in G direction. So there is another force acting in which direction? Radially outward, that is normal. So I can say this is my normal force and this is my radial direction. So what I can do, I can take the component of G along this direction, isn't it? What will be this angle? This angle is theta, so this
Theta.
is theta. So what will be this? So you can write N minus G cos theta is equal to M into AR, and M will also you will use. Yes? Correct or wrong?
Yes, sir.
Yes. And what is your AR? N minus mg cos theta is equal to M. What is this value? R double dot minus R theta dot square. Isn't it?
Yes.
And every time if you are on the surface of this particular sphere, then I can say R is equal to capital R is equation of constraint. लिख सकते हैं या नहीं?
Yes, sir.
R is equal to capital R is equation of constraint. So you can just go for R dot must be equal to 0. And obviously R double dot is also going to 0. And what will happen at theta is equal to theta c? What will happen at theta is equal to theta c? क्या होगा?
Normal reaction is 0.
Normal reaction is 0. So now I have my equation. I will put equation of constraint here. So minus mg cos theta is equal to, what is this particular value? Is 0. That is minus m r theta dot square. And this is at the theta is equal to theta c. Now second thing, we can easily use conservation of total energy. Use कर सकते हैं या नहीं?
Yes, sir.
So what will be initial energy? What will be initial energy? क्या होगा? Only potential energy. So that value is mg r plus r. Sorry, that value here is mg2r, isn't it? mg2r. This is your r. This is your r. So this is mg2r. So this potential energy will convert into kinetic energy plus potential energy, isn't it? So what will be kinetic energy at theta is equal to theta c? Half m r square theta dot square plus what is potential energy at this point? At theta is equal to theta c?
mg r minus r.
Yes, that will be mg. That value is mg r plus r cos theta. Now, the real challenge is that what will be theta dot square here? So from here, we can easily calculate what will be theta dot square. Calculate कर सकते हैं क्या यहाँ से?
Yes, sir.
Yes or no? And this will be some theta c. So you have 2 mgr is equal to, so you can write here r square. So you have half mr theta dot square. So you can write this minus sign and this minus sign is cancelled. So you can write half mg r cos theta plus mg r plus mg r cos theta c, and this is also cos theta c. And you can have these two things will be added. This will be mgr plus this will be what? 3/2 mgr cos theta c, isn't it? What is your theta c?
Cos inverse 2/3.
That is your cos theta c is equal to 2/3. You remember your plus two में आपने पढ़ा होगा. कई लोग तो इसको याद करके ही रख लेते हैं, isn't it? So at the angle theta is equal to cos inverse 2/3, the particle will just going to slide down. Are people comfortable?
सर यहाँ जो हमने पोटेंशियल ली ना वो mg into r plus r cos theta.
ऐसे लिया, देखो ये हाइट लिया, नजर आ रहा है? You have to take this height, isn't it? So this is mgr and this will be r cos theta. We are taking this one as a reference. Yes?
Yes,
ठीक
sir.
है?
Got it, sir.
Okay. This distance, this is r cos theta, this is r.
Okay, sir.
So you can use conservation of energy and you can use the equation of motion only in r direction. Theta direction is not needed to calculate anything. So you can easily calculate it. So last question पर चलते हैं, last but not the least. Clear है यहाँ तक? Everyone, ये सारे
Yes.
क्वेश्चन आ सकते हैं आपके एग्जाम में किसी न किसी फॉर्म में, और आ भी चुके हैं एक्चुअली. ओके ओके, लेट्स ट्राई टू गो फॉर नेक्स्ट वन. So there is a surface of table. This is your surface of table and there is hole on a surface of table, and each and every problem is given in your booklet also. So don't worry. So you can revise from there also. So this is a hole and there is a mass m1 is constrained to move on a surface of table, and this mass is m2, which is just going to hold, just going to hang vertically, and the length of string is equal to L. So what do you have to do? You have to write the equation of motion for M and equation of motion for M1 and M2. So M1 is moving on a surface of on a two-dimensional plane. So we can write the equation of motion for M1 in a polar coordinate, isn't it?
Yes, sir.
लिख सकते हैं ना?
Yes.
Yes, sir.
And M2 is moving in a vertical direction, and it can move only in vertical direction. So we can write the equation of motion of m2 in which direction? In the Cartesian coordinate. लिख सकते हैं इसे?
Yes, sir.
Yes.
Yes. Okay. So let's try to go for writing equation of motion. So we have to write FR is equal to MAR. लिखेंगे इसे. And this will be some distance R, and this will be L minus R. Yes. Because this can go towards or away from origin, and it can rotate also. Isn't it? This type of motion can be possible. So what is FR here? Which type of force is acting here?
Centrifugal.
Centripetal.
Nah. This is blunder. Centripetal force will come into this side automatically, isn't it? Are you getting my point or not? The centripetal force will come in this side when you will write the R. What will be MAR? कल तो यही बताया था. MR dot minus R theta dot square. So you have the centripetal force here, isn't it? So what is your external force? You have to write only external force here. What will be that?
Gravity.
Ah,
सर M2 पे gravity लग रहा है तो
M2 पर ग्रेविटी लगेगा, M1 पर तो वो वर्टिकल है ना. ऐसे मेरे हाथ पर ये चौक रखा हो तो ग्रेविटी और वेट तो एक दूसरे को कैंसिल कर देगा.
ओके सर.
So there is no need to use this thing because there is not any vertical motion. You are absolutely correct. आप ये बोल रहे हो mg is equal to और m1g is equal to n. That's it. खत्म. कोई मोशन तो नहीं हो रहा है ना वर्टिकल डायरेक्शन में.
Yes, sir.
Okay. Now just tell me what is your f? बताओ पुनीत बताओ क्या होगा?
The tension that होगा.
Tension. Exactly. This is your tension. And this tension is developed due to this particular mass. And obviously this is in r cap direction. So we will take minus t is equal to m r double dot minus r theta dot square. What will we have theta? M a theta, that is equal to m r theta double dot plus 2 r dot theta dot. What is f theta?
Is it uniform circular motion?
There is nothing said that it is uniform circular motion. What is f theta? External force in a theta cap direction, something like this. कोई force लग रहा है क्या?
No, sir.
No. So this is 0. So is that angular momentum of first particle is conserved?
Yes, sir.
Yes, angular momentum of first particle is conserved. And some people who have, mainly net people, we have done this problem from Lagrangian also. You remember?
Yes, sir.
हम लोगों ने इसे Lagrangian से भी किया था. For the net people mainly I am talking about. And you can see that angular momentum is there also conserved. You can just go and revise this particular problem. But I am just using the Newtonian here. Now let's try to go for M2. So what will be force into M2? In which direction? Z cap direction. So you have M2 Z double dot is equal to Fz. What is this particular Fz? What is Fz?
mg minus t.
Hmm?
d2g minus t.
Yes, that value is M2g minus t is equal to M2 Z dot. And now, what is equation of constraint? What is equation of constraint?
Length.
Length. So that will be R plus Z is equal to L. This is your R, this is your Z. R plus L is equal to Z means R double dot is equal to minus Z double dot. Isn't it? R double dot is equal to Z double dot. So you can write M2G minus T is equal to minus M2 R double dot. So this is your equation 1. Here is equation 2. You can easily find your T here, and you can write your R dot also.
Sir,
Hmm.
sir, tension की direction towards the hole.
So towards the whole, I have taken negative. So here is also negative.
Oh, okay, sir.
Okay. Just go
Yes,
for
sir.
Atwood machine. Same direction, na?
Yes, sir. Yes, sir.
So you have to be very much careful for the direction of tension. Okay.
Yes, sir.
Okay. So now you can solve it for different cases. And one of the very famous case is that find the angular velocity omega of first particle such that it is just going to hang vertically at distance h. So how you will go for this? It is just going to hang. It is not going to move. You have to just find the angular velocity theta. So what will happen? R is equal to L minus h and Z is equal to h. So what will happen to R dot? That value is 0 and R double dot is also 0. This is very famous question. You can always have this type of problem. So now we can get the angular velocity. So what will happen? Minus tension is equal to minus m. What is R? L minus h theta dot square, and which is basically omega square. You have to find this particular omega, and you can find the tension from here. So what is this? T minus M2G is equal to, and what is this particular thing? This particular thing is also 0 because R double dot is going to 0. So you can add it and you can get the value of omega. आ जाएगा आपका? What is omega? Root under G upon L minus H. So at this particular omega, this is just going to hang vertically at distance h from the surface of table. So you can easily calculate it. Yes?
Yes, sir.
Okay, good. So this type of problem can come into your exam. So you can just go and revise and you can just solve your booklet question. This is more than enough. And in the next class, we will go for a very important topic, that is central force problem and Kepler's problem. Okay. So we will go in this topic into next class. If you have any doubt, you can just ask me.